Otto Construction is excited to welcome you to the future home of the Powerhouse Science Center, located at 400 Jabun Street in Sacramento. This facility has been designed as a space where children can experience science and nature through interactive programs and exhibits. The new center will serve as a regional hub for the promotion of science, technology, engineering, and math education in Sacramento and the surrounding counties. Educational programming and exhibit experiences will help shape the next generation, enabling and promoting innovation. The existing building was first built in 1911 and is currently listed on the National Register of Historic Places. The facility produced electricity as an auxiliary power plant for Sacramento. In 1924, PG&E upgraded the facility, making it the largest steam turbine power plant in the area. The plant was then decommissioned in 1954. In 1957, PG&E sold the building to a metal scrap company, and in 1960, it was sold to the state of California. The building remained vacant for 60 years. In 2002, the city of Sacramento purchased the building from the state of California. Powerhouse Science Center has worked with the city of Sacramento, Otto Construction, Dreyfus and Blackford Architects, and Buehler Structural Engineers in a collaborative design-build effort for the past 14 years. This team of professionals, along with many others, including multiple state and local agencies, have worked very hard in preserving this historic structure and turning it into the Powerhouse Science Center's new and modern $52 million facility. Let's take a look at the construction process of this iconic project. The new addition has been designed for protection against natural disasters such as earthquakes. Sheet piles, shown in the upper left part of this photo, have been installed at the south end of the site to protect the new building addition from liquefaction of Matsui Park that may occur due to a large earthquake. During design, the structural engineer was concerned with the stability and strength of the existing walls and roof of the building, so temporary measures had to be implemented. Massive concrete footings were placed around the building to support the temporary steel wall bracing while demolition was performed. Over $2.5 million was spent on this temporary shoring system to save this historic building. The temporary steel took approximately 3 months to install. The old turbine room basement, as shown here, had to be filled with crushed rock before demolition began. Selective demolition had to be performed by a remote-controlled demolition hammer called a Brock, which was specifically purchased for this project because it was considered to be the safest way to remove the concrete roof and east wall. This photograph shows the historic building after the demolition of the roof and east walls with the Brock. This photograph shows the second floor being demolished. On the left side, you can see the plastic containment covering over the west wall for lead paint abatement. This photograph shows the demolition of concrete and steel at the first floor boiler room. The basement had to be excavated around the perimeter walls so shotcrete could be installed to reinforce the existing walls. This is a photograph from the basement before it was backfilled. All the concrete was removed from the existing steel and inspected by the structural engineer for corrosion, with only a few columns in the boiler room requiring partial replacement. All the exterior existing steel was painted with an armor coat paint that prevents corrosion. This photograph shows the drilling rig equipment used to drill the displacement piles for the new addition. There were 84 piles, each approximately 80 feet deep. This photograph shows the historic building after demolition was complete, with the footprint of the new addition taking shape. Here we have the Vasco Electric and Camblin Steel crews working on underslab electrical and rebar. Due to the sandy river soil on the site, the foundation system required displacement piles as shown in previous photos, and pile caps and grade beam tying them all together as shown here. This is a pile cap that ties the new addition footings into the historic building's foundation system. In this photo, you can see some of the underslab conduits and plumbing for the new addition. On the lower left of this photograph, you can see the elevator pit being formed. This view from Matsui Park shows the slab rebar over the yellow vapor barrier. Here, Otto Construction's crew is placing the concrete slab for the new addition. Here is the slab the next day. Otto's concrete crew is saw cutting control joints in the slab. As you can see, some of the yellow vapor barrier is still visible. These are the closure strips for the tilt-up panels. 24 structural wall panels were cast and cured on site, with the largest panel weighing 54 tons or 108,000 pounds. Each panel was then lifted off the rat slab by a crane and set in place. This process took only 2.5 days. Fast forward to our most recent drone footage, you can see the site from the north looking south. All the single-ply roofing on both buildings has been complete. The weather hood on the roof of the historic building is done, the mechanical units on the new addition have been installed, and the planetarium dome frame is complete. Here is a view of the lobby. The ticket counter will go under the stairs. This is the second floor in the turbine room of the historic building. This area will be used for exhibits. The second floor of the boiler room will also house exhibits. Notice the original trusses and open ceiling. All the ductwork, piping, and conduits will be painted gray so the historic trusses stand out. Otto's daring drone pilot flew Maverick the drone through the top of the dome, showing the intricate framing of the dome structure. The view from inside the dome shows scaffolding in place in preparation for the next phase. On the west side of the building, you can see the original PG&E sign remains. You can also see the crack repairs taking place on the historic facade. The building's west side was originally its front. When it was built in 1911, the river served as the freeway of the time. The new main entrance is on the east side. This rendering shows what the building's south and west elevations will look like when it is complete. On behalf of Otto's construction team of Brian, Steve, Zach, and Constantine, thank you for visiting. The Powerhouse Science Center is on schedule to be completed December 29, 2020. Until next time.